Okay, this time we're going to do a half size magnet array. My other one is a 1/4 inch. This is 1/8 inch magnets. 1/8 inch cubes. 100 and some odd individual magnets. All 1/8 inch. So you can see the comparison. This is my 1/4 inch array. This is 1/2 inch. Or 1/8 inch. Okay, so we're going to do the same thing as before, so we can study how these non-magnetic balls like to move under a magnetic field which is chopped up with individual magnets. Okay? Now, I know that magnetism is conservative, meaning that when you cram a bunch of magnets together like this, they become one magnet. But I just want to test and see if that's really true. So here's the steel balls. Now, I'm going to bring the magnet array under from below. Twisting it, and it doesn't move any of the balls. And I gotta be real here. I thought if I twisted it, because it's many magnets making up one magnet, that it would make these move around in circles. But it turns out that's not how it goes. See, these arrays have a hole in the bottom for a reason. Because what you're supposed to do with this experiment for real is bring them around like this on both sides, and then drop the BBs in through the middle so that they're in this middle section where the hole is, and then that will give you self-organizing magnets. But since we're just using one array, then we're getting these weird effects. Now, another thing to notice here is the plane of the magnet, okay, is where the field is the sharpest. And then in the center of this lip, there's a bright line you can see on the magnetic viewing film, because technically the North Pole is this way and the South Pole is out here. And so the dividing line goes concentric around the lip of the array, because each magnet is a cube, and the cube is shoved in here like this, and so one pole is out here and one pole is in here. Okay? Now, the line where the two poles are divided is the important thing. And I was telling you this about orbits, because when you think about the planets and their magnetic field, people want to think that the Earth is one magnet with just one pole, but actually it's more like this, where each hemisphere has lots of magnets within it. And then when you have it sitting out here like this, moving around, let's see if I can do it. That's it. Shit. Okay. Let's see. And now you notice the magnets want to stick right here between the poles. That's the important spot, because in the whole entire solar system, hang on. in the solar system, the sun is out here like this, and then the planets move around like that. And the plane that they orbit around is literally that plane between the poles, because they are also magnets, all right? And they might be spinning, which pushes them further out around here, but still they always are going to orbit around this central pole, okay? Because it's not so much the poles out here that's bothering everything, it's that this thing has a field around it like this, okay? And that field is divided sharply in half. And if you put another magnet out here inside of it that's spinning, you'll get that quantum locking thing, and then they'll just dance around in circles. But the thing you have to understand is they orbit where they do because of the division between the poles. And each magnet, like take the Earth is basically a ball of iron, much like our steel balls here, and it's sitting in a magnetic field, so now it is a magnet, okay? And then when we go back to the dish, you can see how they want to sit forward. If I turn the magnet sideways like this, we'll try this one with the bigger hole and see. Okay, one more thing. Let's drop the number of BBs. Let's drop the BBs down to just 2 BBs. Okay. Now what I want to do is I want to get them to sit in this empty spot where the magnets aren't. See how as I move them around within that spot, they separate. They dance around each other. Because this whole thing is about magnetism and lack of magnetism. It's not just the pole that's important, it's the dividing line between the poles. See how they divide themselves? This is why magnetism is so important, and understanding magnetism and how magnets link together, how the poles play against each other at the equator. This is why it's so important. Beautiful. Be a free thinker.